This is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In this video, we are going to see about ion-selective electrodes, their precision and the real-time measurement. So what is this ion-selective electrode? These ion-selective electrodes have revolutionized the analytical chemistry by providing a method for specific ion detection. So, the presentation will dwell into the underlying chemistry of the ion selective electrode and explore their practical real time applications. These powerful tools are essential across the diverse fields, that is, for example, medicine, environmental monitoring to industrial processes. So, what is an ion selective electrode? An ion selective electrode is a sophisticated transducer that converts the activity of a specific ion in a solution into an electric potential. This potential can be measured to determine the ion's concentration. So, ion selective electrodes are designed to measure a wide range of specific ions, including the common ones like H+, Na+, K+, Ca2+, and F-. The operation is fundamentally governed by the Nernst equation, which describes the relation between the measured potential and the ion's activity. How IC works? So, ion selective membrane. It is the critical component. This membrane possesses selective permeability, allowing only the target ion to pass through while blocking others. The selectivity is what makes ion selective electrodes so precise. So you will have an n number of ions in the solution, and the ion selective electrode will allow only certain ions to pass through it. There is an internal reference electrode, internal filling solution present in the ion selective electrodes. Typically, the internal reference electrodes are silver chloride electrode. It provides a stable and constant reference potential within the ion selective electrode, which is crucial for the accurate measurements. Internal filling solutions are nothing but it contains a fixed known concentration of the target ion. It helps establish a stable potential difference across the membrane. The potential difference generated across the ion selective membrane is directly proportional to the activity of the target ion in the external sample solution. So, this allows us to measure the quantitative analysis of a given sample. There are different types of ion selective electrodes. The very common one, which we are aware of, is the glass membrane ion selective electrode. There are the most common type, primarily used for pH, that is H+ ions, and the monovalent cations like Na+, and Na+. A classic example is the pH electrode, which is selectively permeable to the hydrogen ion. Next is the solid state membrane ion selective electrodes. Utilizing crystalline or polycrystalline materials, these ion selective electrodes are ideal for measuring the anions such as Fm-, Cl-, S2-, as well as some cations. Liquid membrane ion selective electrodes. These electrodes incorporate the ion exchange or neutral cations dissolved in an organic solvent. They are particularly effective for detecting larger organic ions and important biological cations like K+ and Ca+. The potassium ion selective electrode using the valinomycin is a prime example. What is the advantages and limitations of ISC? Advantages: the real time, that is direct measurement without external sample pre-treatment, saving the time and resources. Non-destructive analysis with rapid response times, typically within the seconds to minutes. Portable and cost effective for on-site analysis, making them suitable for field application. Wide dynamic range, generally covering the concentration from 10 to the power minus 1 to 10 to the power minus 6 molar. Limitation: susceptibility to interfering the ions can affect the accuracy due to selectivity issues. Limited accuracy at very low concentration, requiring Careful calibration. Drift. The necessitates frequent recalibration to maintain precision. Membrane fouling and limited lifespan can impact performance and require